Hello everyone, myself Irene Barwa, Assistant Professor in the Department of Computer Science and Engineering in Assam Downtown University, and I welcome you all to my second video on digital image processing using MATLAB. So today I'll be explaining on the negative of an image, a simple MATLAB program to obtain the negative of a grayscale image and the output of the program. So what is negative of an image? In negative of an image, we represent the darker pixels with lighter and lighter pixels with darker. So I will show you how it looks after doing the program. So first we use CLC command, which is used to clear the command window. Then we use clear all command, which is used to clear all the variable names and their value displayed in workspace. Then we use the close all command, which is used to close all the previously opened images. So regarding these commands, if you have any doubt, you can refer to my first video. Then going on to the next command, I am using the inread function. So here I am using this command to scan the image present on the computer. Then next is the command which is used to get digital image in the form of size m into n. Now I will take one more variable to represent the negative of an image. Let's say its ineg is equals to zeros of m comma n. So this command will create a size of matrix m comma n, which is similar to the original image with all the zero values. Now next I will define max value pixel. So to get the maximum valued pixel of the original image, that is the element with the highest value in the original image matrix, we can use the command max. So you can notice that I am using max 2 times here. Now the purpose to use 2 times max is that it will give me the highest valued pixel present in the original image. If I would have used a single max, then it would have returned me the position of the highest valued pixel as well as its value, but I am only interested in the highest value and not the position. So I am using max 2 times here. Now next I go for the for loop. That is, here for I equals to 1 to m, it covers all the rows. Next, for j equals to 1 to n, this will cover all the columns. And now to represent the negative of an image, I will use ineg I comma j equals to max value minus I of I comma j. So ineg I comma j, here I am taking every pixel of ineg, that is the negative image, and I am changing its value by typing max value minus I of I comma j, where I is the original image and I comma j represents the elements in the original image matrix. So this is the syntax to replace darker pixels with lighter and lighter pixels with darker. So then we will just end the for loop. Now to see both the original image as well as the negative image, I will use the subplot command. So here subplot 1, 2, 1, where 1 is the row, 2 is the column, and 1 is the first image. So the first image is in show of I, which is the original image. I can also give a title to it with the title command. Say I give it as the original image. You can give any title, it doesn't matter. So to see the negative image, I will again use the subplot command. So subplot here basically splits the screen according to our requirement. So subplot 1, 2, 1. So here this 2 will represent the second image. Then show UINT8 INEG, where INEG is the negative image, and I give the title as negative image. Okay, so I used UINT8 here command because we know that this command basically converts the double values into integer, that is whatever values in the negative pixel are in the form of double are converted into integer type. So when you run this program, you get two images, as you can see here. So the first image here is the original input image, and besides that is the negative image. So the original image here has darker pixels and the negative image has the lighter pixels. So this is all about today. Thank you.